Now, how can an analyst use information about marginal cost and demand to identify the profit maximizing quantity for a perfectly competitive rule? The simple rule is find where price equals marginal cost. When the competitive firm produces the output that makes price equal to marginal cost, it will maximize profit. It's a simple application of the marginal cost, marginal revenue discussion we had in the previous lecture. Price is marginal revenue for the perfectly competitive firm. So when price is above marginal cost, then an increase in output will make profit rise. So whenever price is above marginal cost, you want to increase quantity. If price is less than marginal cost, then an increase in quantity will make profit go down. That means do not increase quantity when price is less than marginal cost. You're going to wind up, you put these two things together, it means you want to produce the quantity where price equals marginal cost, or you want another way to do it is to say that you want to increase quantity as long as price is greater than marginal cost, and then stop once price gets below marginal cost. Simple example. I have a table. It tells me, gives me information about quantity. Quantity goes from 0 to 8. Total revenue goes from 0 to 48. Total cost goes from 3 to 47. Profit goes from -3 to 1. Marginal revenue stays at 6. That tells me that here the marginal revenue is constant at 6. That means the market price must be $6 for this competitive firm. In perfect competition, price and marginal revenue are always the same. By subtracting the differences in total cost, we can find that the marginal cost goes from 2 to 3 to 4 to 5 and on up like that. Now, when output goes from 0 to 1, marginal revenue is greater than marginal cost. That means profit rises. The firm wants output to go from 0 to 1. The quantity goes from 1 to 2. Again, marginal revenue is above marginal cost. Profit will rise. 2 to 3, marginal revenue above marginal cost. Profit will rise. 3 to 4, marginal revenue above marginal cost. Profit will rise. And we go from 4 to 5. Here, the marginal cost equals marginal revenue. In that case, profit will not change. When we go from 5 to 6, marginal revenue is now less than marginal cost. Danger, 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 Will Robinson. That means your profits are going to fall. So your profit maximum, in this case, you've got two quantities that will maximize profit. It's the last unit where marginal revenue is above marginal cost. It's also the unit where marginal revenue equals marginal cost. Both of those gave us a profit of $7. Notice, I found the profit maximum quantity was 4 or 5 without looking at profit. I did it by comparing marginal revenue, marginal cost. I found the last unit where marginal revenue, or where price was above marginal revenue. And I found the last unit, and I found the unit where price equaled marginal cost. Both of those give us the profit maximizing quantity. In this case, we have two quantities that maximize profit. We can do this pretty easily on a graph. I'm just going to sketch something nice and pretty here. Let's do that. We'll do quantity. We'll put dollars up here. Let's suppose the firm's average total cost curve has a minimum quantity of 20 and the minimum is $10, just for grins. I know that marginal cost, let's start that one over. I don't like that one. Let's say that marginal cost, yeah, it's better, as upward sloping curve. It must intersect average total cost to the minimum average total cost. And let's just for grins say, we'll do this in blue. You know, we'll stick a bit of red. Let's say the market price is $15. That means the demand facing the firm is horizontal at 15, and the demand curve and the marginal revenue curve are the same. To find the profit maximum quantity is really easy. You simply find where marginal cost intersects the demand curve. That's where marginal revenue equals price. I'm sorry, that's where marginal revenue equals marginal cost. It's where price equals marginal cost. We drop it down like that. That's going to be maybe 22. The profit maximized quantity is the quantity where the demand curve intersects the marginal cost curve for the perfectly competitive firm. Now, once you found the quantity, it's very easy to find the maximum profit. You can find the maximum profit by following 3 simple steps. Number 1, use information about price and marginal cost to find the profit maximized quantity. We did it for our table. We did it for our graph. Second, identify the average total cost at this quantity, and then plug price, average total cost, and quantity into the formula profit equals price minus average total cost times quantity. Let's see how that would work on our last example. So let's work through an example now with the with a table. I've got quantity going from 10 to 12. The market price is 20. That tells me that marginal revenue is also always 20. When output goes from 10 to 11, marginal revenue and price are higher than marginal cost. That tells me profits are going to rise. When output goes from 11 to 12, marginal revenue and price are now less than marginal cost. That tells me profit will fall. So 11 is the profit maximizing quantity. To find the maximum profit, I simply plug into my formula, profit equals we'll get it, equals price minus average total cost times Q. I know the price is 20. The only average total cost I need is the one at the profit maximizing quantity. I know the quantity of 11 maximizes profit, so the relevant average total cost is $12. I multiply it by the quantity, which is 11, and I get a grand total of $88 as my maximum profit. We can also do this on the graph. Let's see if I can repeat it. I got quantity, I got dollars, had average total cost, hit a minimum at 20, and that was $10. And then the demand and marginal revenue were horizontal line at $15. And I had my marginal cost coming through like this, marginal cost, and the profit maximized quantity was 22. Now to find profit, all I've got to do, well, I know price is 15. I know quantity is 22. I now need to know the average total cost when quantity is 22. The height of the blue dot is the average total cost when quantity is 22. Maybe it's $11. All right. So profit will equal my price, which is 15, minus my average total cost, which is 11, times my output, which is 22. That'll be 4 times 22, or $88. Now this profit can be represented very neatly on the graph. The difference between 11 and 15 and 11 is the horizontal distance. I'll make it in green here. It's that distance right there. 15 minus 11 is $4. The height of that green line is also $4. It's the difference between 15 and 11. Ooh la la. 22 is the horizontal distance to the, I'll make it purple. 22 is the horizontal distance that way. You notice I'm forming a triangle, a rectangle here. I've got the rectangle is bounded by the demand curve, the quantity, the green line, the purple line, which is the average total cost at the profit maximum quantity, and the horizontal axis. And when I find profit, I multiply the height of the rectangle, the green line, height of the green line, by the base of the rectangle, the purple line. When you multiply height times the base, you get an area. The area of that shaded rectangle is $88, that area is also the firm's profit. Now we can show what happens with a loss also on a graph pretty quickly or easily. Firms don't always make profit. Sometimes they lose money. Average total cost, there's marginal cost. Let's keep things kind of the same. Let's say it's still 20. Let's say that's still 10. What happens if the market price is only $5? Demand equals marginal revenue. Well, now the profit maximizing quantity is something like 15 units. But the problem now is the firm's price is going to be less than its average total cost. Price equals 5. Average total cost is going to equal something like 12. That means a profit. It's going to be less than 0. If the price you're charging is less than your average total cost, you're going to be losing money. And your loss is going to equal, it'll be the average total cost minus your price times your output. That'll be 12 minus 5 times 15, which will be 7 times 15, which is some number. 5 carry the 3, 105. All right. Well, that 105 is the area of the rectangle I'm going to show you here in blue and purple, I mean. The height of the rectangle is the loss per unit, $7. The length of the rectangle, 15, is the quantity. When I multiply the loss per unit by the number of units, I'll get the loss. I'll also get the area of that rectangle. The area equals the firm's loss of 105.